In this video, we are going to discuss what it means when we say JavaScript is a loosely typed language. We will then look at some examples of how we can improve our code using TypeScript by improving the type safety of it. Then we will go on to discuss TypeScript in a little more detail and whether or not it's even worth learning JavaScript, or if you should just skip it and learn TypeScript. Now this video is going to be ranked a blue belt, so we are going to be keeping it super beginner friendly, and this is a essential video that you need to watch to make sure you have your basics and fundamentals down in JavaScript. You need to know what it means when we say JavaScript is a dynamic language. Now, as you may have heard of, JavaScript is a dynamically typed language, and because of this, a lot of the time it gets a bad reputation. But what does it actually mean to say JavaScript is a dynamic language? It means it is loosey-goosey, flexible, do whatever you want, spaghetti code, not safe, not reliable. But let's look at that in more depth and add some examples of what this means and how type safety can actually prove it. Okay, OVL equals 10, and at some point, you know what, I don't want this to be a number, it can be a string. Now when we say JavaScript is loosey-goosey, what we're saying is we can just do whatever we want. We can declare a variable and have it be a number and then just to make it a string. Now this flexibility might seem cool at first, and it might allow you to do things as you want and give you more control, but as you progress as a software engineer, what you realize is you don't necessarily want more control and more flexibility. You want things to be more safe, more reliable, and boring. So at some point in our code, if we was to check, hey, you know what, I want to know if player level is greater than 25, and if you're greater than 25, you're a bonus level player. Now when I run this code, it says you are not a bonus level player. We're comparing a string to this number and we're getting some unexpected results. You might say, oh well, I would never do this, I would never change this, I would never use this variable in this way. But unfortunately, when you're working in a large code base with lots of other developers, and as your code grows, lots of mistakes can creep in, and the more strict your code is, the more reliable it's going to be and the more predictable it's going to behave when you're in production. So let's see how this looks in TypeScript, a type safety language which is going to check the types of the language before runtime to tell us if there's anything wrong with our code in advance. And as you can see on line 4, it says type string is not assignable to type number. It's type checking this variable and it's saying, hey, on line 1 we made this a number because you declared it to a value that is a number, and you've now tried to use it as a string. There could be some unexpected side effects when we do this. We can also be more explicit if we want to and actually specify this is a number, but often when you're just declaring variables and you're assigning it to a value, you can just let it take care of you automatically. Now it's really hard to appreciate just how much more safer and more reliable TypeScript, or just type safety in general, is going to make your code until you get into a large production code base and you start to see your code behave in unexpected ways. So let's just look at some more examples. So there's a function declaration. Now let's just say we had a function, and this function is going to greet people. Function name, return hello name, greet John. When we execute this, hello John, no problem. Now in JavaScript, because it's a dynamic language, we can pass in whatever we want, right? We're expecting this to be a string, we're expecting the name of a person, but really JavaScript is just going to let you do whatever you want to do. If I want to say hello to a number, I can. If I want to say hello to a boolean, I can. If I want to say hello to an object, guess what, I can. Hello object. I can do pretty much whatever I want to do. I'm just going to let you do whatever you want to do, because it's a loose language and it doesn't care. And here's the other weird things, right? I could say name, and for some reason I want to pass in age, and then maybe you want to say, okay, that's your age. Maybe I want it to pass in height and say your height. But as you can see, this function is now expecting 3 parameters. But look, we're only passing in the 1 parameter, and JavaScript still doesn't care. It's letting us do whatever we want to do, even though we're using this function in the incorrect way. It's expecting name, age, and height, and we're just passing in an object. This is super confusing. So even if I was to pass in John, it's like, well, what happens when I don't pass in those other 2 variables? It just says, okay, well, you didn't pass them in, so they're undefined. Don't worry, you didn't pass these in, but I'm going to take care of it for you. And even if you did put in age, maybe we put in our height, maybe now you can just start doing whatever you want. Now I'm only expecting 3 parameters, but I'm passing in 1, 2, 3, 4, 5. Again, I'm using this function in unexpected ways. But again, it just doesn't care. And again, guys, it's like, well, why would you allow a function to continue to pass in these parameters when it's clearly not expecting them? Now, this may seem obvious at first. Well, I just wouldn't do this in the first place, right? I would just make sure I'm being reliable and a responsible engineer, and I'm not going to use this function in a way that is not expected. As your code base grows and you create this function, maybe you say, do you know what, actually I want to maybe you get a new requirement to improve this, to change this introductory message to say, do you know what, actually we're going to pass in a gender and we're going to pass in this hair color. And then maybe in your code base you have this function, but what if somebody else is already using this function in another file somewhere else and they're not aware that this change has been made and they're still passing in the 3 parameters? Well, everywhere else in the code base where that type has not been checked, it's just going to say undefined, undefined, undefined. Then you get to production and you see this message displaying undefined, and then you find out that this function has actually been updated to include 2 extra parameters, but no one made you aware. Now this all changes again when, so let's just see what happens in a type safety language. So we have function, greet, that message. But now let's say I said, you know what, I'm just going to pass a name. Straight away it's getting, it's like, hey, we expected 3 arguments, but you've only gave 1. An argument for age was not provided. Straight away, these types have been checked, and it's making sure that this function cannot be used in a way that's unexpected. It's checking our types for us, making our code more reliable and safe, and giving us a more predictable outcome as to how this is going to behave in production. So now I know, okay, I've tried to use this function, I need to pass in an age, I need to pass in a height. Wait, what? It says this argument type string is not assignable to a parameter of type number. So straight away, it's made us aware that we're expecting a number. Now you might say, well, this should be a string because I want to be able to put a decimal place in and I want to be able to specify this more accurately. So maybe you can just say, okay, well, I know that this should now actually be a string instead. And there you have it. Hello, John. You are 30 years old. You are 5 foot tall. And now this function is behaving in a more predictable way as we're now using the correct types. This can also happen. We can even improve this function. We can type check the function to say this function should return a string. Maybe we expected a number and now we'll get an error to say your type string is not assignable to type number. Again, guys, making our code more reliable and giving it a more predictable outcome. So they're just a few examples as to how type safety can improve our code by making it more reliable and giving us a more predictable outcome as to how this code is going to behave in production. Now let's look at how this can benefit us when we're using objects. So maybe you have type player. Maybe player has a name, string, age, height. Maybe player has a level, number. Maybe it has a status, which is going to be a string. Now maybe we have a function that's going to level up player, and we pass in player. And hello player, you are 21 years old and you are level and your status is status. Now we have this type. Anything that gets passed into this function, level up player, must pass in an object that conforms to this type or make it an interface. Now let's say I attempt to use this level up player and I pass in a player name. That's great. Age. But you know what? Maybe I've forgotten to pass in status, right? I've made a mistake. I hadn't realized that. I'm like, hang on a minute, what's wrong? I just passed in this player to write this message and log it out, but there's a type complaint. It's saying property status. Oh, okay, great. So it's saying that in order for me to use this function, I actually am missing a property on this object that's being passed in, which is status. And if I do not assign a field called status, then we're going to get an unexpected outcome in our code. And there we go, guys. Now the error is fixed. It's type checks the object that's being passed in and making sure it conforms to the interface player so that we don't get any errors in after the code has been compiled in runtime. It's making our code more safe and more reliable. So there's just a few examples of how we can use type safety in TypeScript to make our JavaScript code safer, more reliable, and behave in a more expected way after it's compiled in runtime. So in the year 2025, you're probably not just going to be using JavaScript anymore in a production code base at a enterprise level. TypeScript gained so much popularity and it has so much benefits that it gets used in almost every enterprise code base. And the only time you really see JavaScript now is when there's a bit of legacy code that's hanging around that hasn't yet been put into TypeScript. So with that in mind, TypeScript's great. It makes our code more reliable. It makes it safe. It does all the type checking for us to make sure that our code is more reliable in production. So what's the point of even learning JavaScript? Shouldn't I just skip JavaScript and go straight to TypeScript? Now, the thing is, TypeScript is just a subset of JavaScript. TypeScript is just JavaScript with the extra layer of type safety to type check your code and make sure the types are being used in an expected way. And a lot of the time, when it just comes to learning TypeScript or looking at the TypeScript documentation, TypeScript just focuses on the type safety part of your JavaScript code. So it will talk about using interfaces, types, aliases, etc. But it doesn't actually teach you all the other stuff that you need to actually code right. So even if you look up a TypeScript tutorial on YouTube, for example, and you say, I'm just going to learn TypeScript, yeah, it might show you how to type a parameter, how to type an interface, how to use JavaScript, how to type safety your function to return this, but it's not going to actually teach you how to code. It's not going to teach you everything else other than the type safety stuff that you need to be a software engineer. Also, like I said, when you're working in an enterprise code base, there's probably still going to be a bit of JavaScript lying around from a few years ago, and it's going to be important to understand what's going on without the TypeScript. So you should 100% be using JavaScript. Also helps to understand all of the negative stuff that comes with JavaScript being a dynamic language that's flexible and lets you do whatever you want, and that's going to give you more of an appreciation for how much additional benefit you're going to get when you're using TypeScript to get that type safety. So 100% you should be learning JavaScript, learn it inside out, and then learn TypeScript on top of it, and just understand that TypeScript's just adding that type safety to your code base. So just to recap, guys, we discussed what it means when we say JavaScript is a dynamic, loosey-goosey language. We also discussed what a static type language is, and then we went through some examples of how we can use a static type language in TypeScript to improve the type safety of our code and make it more reliable. Then we went on to discuss if it's even worth learning JavaScript, which of course it is. You should 100% learn JavaScript inside out, and then go on to learn TypeScript on top of that to understand how to implement type safety into your code and make it safer. So that's a wrap. We're going to end it there. If you got any value from the video, please like it, and if you want to make sure that you receive a notification on the next series, on the next video in the Blue Belt series, then make sure you are subscribed.